Talked a lot about motion in the last video. Motion of planets, motion of balls and springs, and even light itself. But what are those things that are moving around made of? What's the planet made of? What are you made of? In this video, we'll talk about the great people who investigated these questions and what kind of answers they came up with. Democritus. Now you have to remember, before physics was formally brought into use as a word, these curious investigators were called natural philosophers. Around the year 430 BCE, the Greek philosopher Democritus put forth his idea that all matter is made of indivisible, invisible particles, which he called atoms, from the Greek word atomos, meaning indivisible. Democritus was from the city of Abdera, Thrace, Greece, and lived from about 460 BCE to 370 BCE. Not much is known about Democritus, apart from the fact that Socrates praised his ideas and passed them on to Plato and Aristotle in Athens. Now it's important to note here, Democritus' idea of the atom is that, quote, atoms differ in size and shape, but materially they are all the same. There are an infinite number of atoms in the universe, and they move about in empty space. The movement of atoms is entirely random, undirected by any cosmic force. You'll see this is quite different from the modern idea of the atom. It would be some 2,000 years before an alternative theory comes along. John Dalton. John Dalton was born September 6, 1776 in Eaglesfield, England. Dalton was a chemist, often studying different chemical compounds such as methane, ethylene, and nitric oxide. Just imagine it, people are mixing and messing with all these different chemicals with no idea of the parts and pieces that make them up. Dalton introduced the first modern view of the atom while studying the atmosphere in the following revolutionary ways, of course with some errors. 1. Elements are made of extremely small particles called atoms. 2. Atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. 3. Atoms cannot be subdivided, created, or destroyed. 4. Atoms of different elements combine in simple, whole number ratios to form chemical compounds. 5. In chemical reactions, atoms are combined, separated, or rearranged. To my knowledge, only one of these is incorrect in terms of our current understanding of the atom, because atoms can, in fact, be subdivided, created, or destroyed. John Dalton had started the human race on a journey to uncover what everything is made of. It would be almost 100 years before another, more viable model would come along. J.J. Thomson. Sir Joseph John Thomson was born December 18, 1856 in Manchester, England. Thomson was on his way to becoming an apprentice engineer to a train manufacturer, but his father died suddenly in 1873. He went on to attend Trinity College at Cambridge University in 1876. Then in 1884, after a very successful academic career in mathematics, Thomson became the Cavendish Professor of Physics at Cambridge. Of Thomson's research assistants, a whopping 6 of them went on to win Nobel Prizes in physics. In 1897, Thomson realized that cathode rays within a vacuum could be deflected by an electromagnetic field, indicating to him that atoms can be divided into smaller parts, a positive and negative part. Thomson proposed what is called the plum pudding model of the atom, which states that atoms are positively charged spheres with embedded negatively charged electrons, like the raisins embedded in a plum pudding. Gross. This allowed the atom to stay neutrally charged due to the even distribution of the electrons in a, quote, uniform sea of positive charge. Now you'll see that the ideas get more and more specific here, in terms of the theory behind what makes up the atom. Unfortunately, because they're getting more and more specific, they're getting more and more wrong. Ernest Rutherford. Ernest Rutherford was born August 30th, 1871 in Brightwater, New Zealand. Finally, some non-Brits make their way into the picture. A gifted student in his homeland of New Zealand, Rutherford moved to England, of course, in 1895 to study at Cambridge, later going on to replace J.J. Thomson's role as the Cavendish Professor of Physics. Ernest Rutherford is most famous for his gold foil experiment, which he conducted in 1911. By hanging a sheet of gold foil with a detecting screen around it and firing alpha particles, the nuclei of helium atoms, at it, Rutherford noticed that almost all of the particles would go straight through to the other side, but about 1 in every 1,000 would get bumped and deflect in a different direction. This led to Rutherford's nuclear theory, which states that atoms are actually made up of a small, densely packed, positively charged nucleus and are surrounded by negatively charged electrons. Rutherford has been described as, quote, the greatest experimentalist since Faraday. You'll remember him from part 1. We're getting closer still to the modern idea of the atom. Again, I think this video is going to run a little long, so we'll continue next time with part 3. In the next episode, we'll talk about some new, even more accurate models and introduce the favorite buzzword of pop science journalists and superhero fans alike, quantum mechanics. Thanks for watching, and see you next time for more great people in physics.